morning. This is Sunday morning. As I'm going to give you an outline of the review for this course up to now. And so I have this blank sheet of paper, and then we go by week. From week one, we primarily reviewed our algebra. Of course, we covered some, algebra, not in great details, for obvious reason. So at this point, if you have any questions about any one of these algebraic issues, feel free to reach out to me. I will do my best to give you hopefully some useful tips, okay? But primarily that you have to put your pencil to the paper to work it out. The first important concept we have is limit. That's we covered this semester. And the second one is continuity. And the next one is derivative. And the last one, okay, I'm going to put the last one somewhere on the same row, okay? The last one is integral. Let me make the font just a little smaller so you can see it all, right? So these are four major concepts. And so we covered them in this order, and we know that limit was first introduced. So what are going to be tested, right? So we also have that flashcards that I mention often. So let me put it under to see that fits on the page. And I will share the screen with you. Okay, let's do it this way. The middle part. And the flashcard. Maybe I put it right here to see if you can see that. I'll put it in the middle. Let's see if we can share the screen. Okay. We'll have a share screen. Just 1 second. New share. So all three. So we have covered 4 important concepts. Okay. And of course, the first week we have we have covered limits. And what are the questions? What kind of question will be on your exam? They're all from your homework. They will all be from your homework. So when you review the homework you have done, be mindful of what principle is being used, what definition is being used for that particular question, and why you do each particular step. So that's what I'm asking you to do, because now the homework you've done will be your resource to review those materials. For example, we start from the first week, right? We started with the 6 principles, and then it's about limit. For limit, we have definition, and then we talk about the concept of limit is the state set. It comes with a definition. The definition describes what that notation tells us what it implies when you put that notation in front of a function. It is basically says that suppose a function is defined when x is near the number of you're taking limit of a. And this means that f is defined on some open interval that contains a, except possibly at a itself. Every time you see that limit symbol, you are in that kind of environment. If you remove that symbol from your expression, then that definition no longer applies. So when you look at the homework questions you're working with, okay, with limit, right, with the expression with the limit or expression without limit, they actually mean completely different things. Okay, and these are the algebraic. For example, in the first set of question here, for the example homework number 2, that all of these are algebraic expressions, and these expressions are for, these rules are happening in the domain of these set functions. And when you put a limit in front of them, it means the definition comes into the picture. So when you review the homework you have done, please reflect the meaning of these symbols. And as a result, when you go through the steps, each step of the way, I wish you to reflect on the meaning and why you do certain factoring, and why you do that is because the limit law is the application, especially on the limit on one-sided limit. You need to understand what it means, right? And what is the environment that you apply. And for example, this theorem is very, very important theorem. So let's go back. Okay, let's go back to our week number 3, right? Week number 3, we have homework. Let's use our homework as a guideline. So you see all of these questions these are purely algebraic, without limit symbol. It means it's a function. It could be, the numbers can be anywhere in the domain of the set function. But once you have the limit sign in front of it, it has changed the meaning of the function, because in these limit setting, we will only be concerned with the neighborhood of the number where we take limit. Okay, so meaning of definition, when you go through those questions, it should always be reflected and be thought of when you study. That is the proper study. So don't get yourself in the autopilot, because once you get an autopilot situation, you're not thinking, so you just do it automatically. That's not going to help you. Okay, limit from size, right? Some of these questions will be, these are being quizzed very much, and these will be on your final exam, because this final exam is going to be a comprehensive coverage of all the materials we have learned. And so here I'm going forward with, one, can you do direct substitution, right? And so on and so forth. When you cannot do limit substitution, it all depends on the definition and the function we're dealing with. Okay, limit law, we can only apply limit laws when each individual limit involved exists. If one of them does not, then you cannot apply limit law. Okay, and this is also said and reflected in our recent study of limit on L'Hopital rule, right? When can you apply that continuity property about the function? So let me bring it back. It showed up a bit earlier. That property was used much in latter chapters, which is, about the composition of limit. And for that question, I went over that property in the recording, in the recent recording about the solution to quiz number 20. So the limit from the side, okay? And it's pretty much going on by the order of the flashcards and order of the homework. And once again, all the questions are on the final exam will be from your homework. So whatever homework you have done, when you review those material, be mindful of each one of those questions you did before, as they are related to the theorems and the properties. And because that's these, these flashcards, they're really what you're learning and to understand. Okay, to realize what the homework require you to do, of course, it requires certain algebra. In a lot of cases require a lot of algebra, but always be mindful of the new things you learned in the course. Okay, so that's about limit continuity, intermediate value theorem. And in the past, I have made some recordings for your to explain to you. And as much as I tried, I didn't want to make those lessons too long. And a lot of these lessons, I believe you have watched. If you don't have time to watch, just select one of those that you find necessary. In the middle of the semester, right, we have a midterm exam. By that midterm exam, we have primarily focused on limit and continuity. And afterwards, we have studied more on derivative. Regarding the relationship of these three concepts, we know these relationships and have been addressed over and over again, that derivative, if a function is differentiable at a point, then it is continuous at that point. So derivative leads to continuity. Continuity leads to limit. Limit exists, but not vice versa. In the reversed cases, right? If limit exists, there are cases continuity doesn't. In the case that continuity is true, but differentiability may not be true. So a lot of these questions actually are related between these two, okay? So you need to have those concepts clear, and you also know that what are the counterexamples, and because typically those counterexamples will show up, okay? All right, so regarding midterms, so by the time from the beginning of semester to the midterm, you will see that the type of questions, of course, will be different from the midterm exam, will be similar to that of the midterm. And the final exam will be similar to some of those quizzes and your homework questions. Each one of these quizzes, I believe we have either have a solution written in writing or recorded lesson, or the solution has been discussed in class. So if you missed those notes, please make sure you make a complete, you get those notes from your classmates. And so by this time we are in, we've done a lot of differentiation, right? In terms of differentiation, we have adding, subtracting, multiplying, dividing, these rules, and in particular, the chain rule and implicit differentiation. All of these are hard topics, and we have been quizzing you. So many of you have picked up, points, but these materials will be tested again. And last, but not last, most recently on differentiation, we talk about the interval of increasing, decreasing. Okay, so let me bring that up. Okay, bring that up on flashcards. Okay, on flashcards. The interval, extreme value theorem is very important theorem. Intermediate value theorem is very important theorem. Theorem about continuous functions. Fermat theorem is extremely important. So from this point on for chapter 4, about critical numbers, the interval of increasing, decreasing, concavity, inflection points. These questions was not on the midterm exam, but they will be on the final exam. You are allowed to bring these flashcards. However, you must have practiced using these flashcards before you come in. Otherwise, you'll be just looking around for cards. That's not going to be very helpful. So card is only, it should be some kind of assistance, but you already know what you understand these theorems. So you understand these theories and connections. You need to make sure you're very familiar with all of these results. So recently, until the week number 14, which is last week, we have covered so many things from differentiability to from week number 9, okay, from week number 8 to week number, I would say week number 13, we've been covering derivative and their applications all the way up to L'Hopital rule. And my recent recording is to explain to you the use of L'Hopital rule. But in week 14, we have already introduced integration. Integration, the definition of integration is it looks pretty complicated, but we have explained that in class. So if you missed the notes, please get the notes from someone, because you're going to take those ideas and use it in calculus too. Now, for the coming 2 weeks, we actually only have 1 week of instruction. I would say 1 week and a half instruction, because our exam is going to be on the 6th. So next week, the material next week will continue on integration. Okay, so on integration, when we learn about integration, and we have talked about the fundamental theorem of calculus 2, of calculus number 2, and we will be talking about fundamental theorem of calculus on part 1. And also we're going to learn the technique of integration, which is substitution. So these are the contents we're going to do next week. So besides reviewing your material, you also have to keep up with these materials that we are going to cover. So the material covered on final exam is all the way from the beginning of the semester until the end of next week. So this review I can do for you right now is pretty brief, and we cannot get into any details unless you have any specific questions, and please send them my way. And for you, you need to study the past material, and study the past material with mindfulness. Okay, as what definition is being used, what theorem is being used, why I do this specific steps, why I need to take first order derivative when we determine increasing, decreasing, and why we take second order derivative for concavity. Why? So all of these is determined by definition theorem and all these theories in the flashcard. Okay. Best yet, if you have you've been reading the textbook, that would be great for you. But if you have not started reading any textbook, that's really your loss. And at this point, try to read as much as possible. And in the future, if you have to take the class again, please just have a good study habit from the get-go. And you need to read those. Okay, you need to read those. I think that's all I can say at this point, unless you have any questions. And I'll be assigning you homework for the last week before the final week, right? And if you have any questions, please let me know. Thank you for watching.